A problem from section 5.1. So we'll jump right on in here. On the first question, we're doing a uniform distribution. It says suppose a randomly selected used battery output voltages range from 3.9 volts to 7.9 volts, uniformly distributed. Okay, so an X is going to be the random battery voltage. So again, this goes from 3.9 up to 7.9. Okay, so the range on that is 7.9 minus 3.9. Okay, so just real quick, I'll do that. And so the range is 4, and so the probability curve here would have to have a height of the reciprocal of that. So this is 4. Okay, and this would be 1/4 vertically. Again, the area has to be 1, so the base times the height has to be 1. 1/4 is 0.25. So the height and the base have to be reciprocals on this rectangle because they have to multiply to give 1. Okay, so the curve up here is y equals 0.25 or 1/4. Okay, so that's the first question here, the height of the curve, 0.25. Now that it says probability that x is bigger than 4.7, so I'll just put 4.7 in here somewhere. Doesn't really matter where it is. And we want to know the probability of being greater than that. Okay, so the problem changes just a little bit. We're still finding the area of a rectangle here, but the base that we're working on here has a width of 7.9 minus 4.7. which is 3.2. Okay, so this area is the probability that x is between 4.7. Oh, sorry, we're doing x is greater than 4.7, my mistake. So x is greater than 4.7. And so that's just the area of the rectangle that I shaded. So that'll be base times height. The base is 3.2. The height is 0.25. So I think this will be 0.80. Let me just see here. 3.2 times 0.25 is 0.8. All right, 0.80 or 80%. But here we'll just put in a 0.80. Okay. Now we'll do the next one. X is less than 6.7. So I'm just going to go ahead and erase all this. And then we're doing less than 6.7. So 6.7, a little closer to the other side this time. And then we want to shade to the left, less than. Sorry, let me get rid of all this stuff. So we're just shading over here. Okay, and so the width of that area is 6.7 minus 3.9. So let's see if we do that on the calculator. 6.7 minus 3.9. And that's 2.8. And then we want to multiply that by 0.25. So we'll just, because again, we're finding the area of this rectangle here. And so we just want to do the base 2.8 times the height, 0.25. So just multiply that last answer times 0.25. And we get 0.7. Okay, so we'll put that in. The probability that x is less than or equal to 6.7 is going to be base times height, 2.8 times 0.25, which turned out to be 0.7. I'll put a 0 for 70%. Okay, and so we'll put that down here in the answers, 0.70. And then one more. So let me clear all this out. Okay, so on this one, we're finding the area between 4.3 and 7.1 on this last one. So I'll go ahead and put a 4.3 in here somewhere. And then 7.1 should be way up there. Like that. And then we'll again shade in here. Okay, and then we'll need to know how wide that is. So that'll be 7.1 minus 4.3. So let's do that real quick. 7.1 minus 4.3 is 2.8. And that sounds familiar actually. So the probability that x is between 4.3 and 7.1 is just the area of the rectangle, which is the base 2.8 times the height 0.25. And I think this is going to be 0.7 again. Okay, so 0.70, again 70%. I'm going to put this in over here. Okay, and then it just says the mean of a uniform distribution is the mid-range. What is the mean of this one? Okay, so I guess they're just asking us to remember the formula for the mid-range. So let me clean this up a little bit. Okay, so the mean would just be here in the middle. Okay, so the mean is the mid-range. And that's just the average of the max and the min. So you can just add those 3.9 plus 7.9 over 2. So let's do that over here. I'm going to use a fraction template. Complicated fraction kind of, so 3.9 plus 7.9 over 2. 5.9. And that's the mean here in the middle of the distribution. So we'll go ahead and put that in. 0.9. Check our answer. Everything is correct, so we're good to go.